Across the globe, a message arrives, not by wires or waves, but by light. This light has traveled for centuries, a final postcard from a dying giant. For generations, we've looked up at Orion, his shoulder marked by the fiery red jewel Betelgeuse. That jewel has just exploded. This is not science fiction. As of today, August 23, 2025, humanity is witnessing a supernova in our own cosmic backyard. Thanks to the James Webb Space Telescope, we have a front row seat. The death of a star is not just an ending, it's a violent, beautiful beginning. The elements that forged our world, iron, calcium, were all cooked in stars like Betelgeuse. We are, quite literally, stardust, now watching the forge in action. The news ripples across the planet. People everywhere turn their eyes skyward, hoping to glimpse this celestial ghost. The light from Betelgeuse's demise carries answers to questions we've asked for centuries. How do stars die? How are the heavy elements made? What does this teach us about our origins? Join us as we explore Betelgeuse's explosive farewell, one of the most significant astronomical events in modern history. The story of Betelgeuse is, in a way, our own story, written in fire across the heavens. Before its spectacular end, Betelgeuse was a true titan, one of the brightest stars in our sky, yet far enough away to pose no threat. It was a red supergiant. If placed where our sun is, it would swallow Mercury, Venus, Earth, Mars, and even Jupiter. Its size was almost incomprehensible, a bloated, simmering giant on the verge of collapse. Betelgeuse was old and unstable, burning through its fuel at a ferocious rate. After exhausting hydrogen, it fused heavier elements, swelling and cooling, its red color a warning of impending doom. Its proximity made it a crucial laboratory for understanding stellar evolution. Astronomers could study its surface, see massive convection cells, and watch it shed matter into space. This behavior offered invaluable clues about the final stages of a massive star's life. For centuries, Betelgeuse was a constant in human culture, a celestial landmark and a ticking time bomb. Its name, from Arabic, marks its place in Orion, woven into myths worldwide. For modern science, it was a cosmic celebrity, watched and studied for signs of its dramatic end. We knew it would explode, sometime in the next 100,000 years. Now, we are the generation to witness it. The first major clue came in late 2019. Betelgeuse was fading. The once brilliant ruby dimmed dramatically, losing more than 2/3 of its brightness. This great dimming sparked speculation. Was the supernova finally beginning? Initial theories ranged from a cool down to giant star spots, but Hubble and other telescopes revealed the truth. Betelgeuse had ejected a colossal cloud of gas and dust. This self-made dust cloud blocked the star's light, creating a cosmic smokescreen. After months, as the dust drifted away, Betelgeuse returned to its former glory. The event was a spectacular demonstration of the star's instability, a surface mass ejection dwarfing anything our sun could produce. In hindsight, the Great Dimming was a dress rehearsal for the main event. It showed Betelgeuse's internal engine was sputtering, nearing the end of its fuel. The dimming was the silence before the thunder. Scientists gained unprecedented data on the conditions preceding a supernova. The stage was set for Betelgeuse's final act. The alert came not with a bang, but with a flood of data. On August 21, 2025, neutrino detectors deep underground caught the signal. Betelgeuse's core had collapsed. The supernova had begun, and the light show was only hours behind. An immediate worldwide alert went out to every major observatory. The James Webb Space Telescope, a million miles from Earth, was ready. As the shockwave erupted, Webb turned its gaze to Orion. The initial burst of light was so brilliant it would soon be visible to the naked eye, even during the day. Webb's instruments saw more than a bright point. They saw the explosion as it happened. In a fraction of a second, the supernova released more energy than our sun will in its entire lifetime. Temperatures soared to billions of degrees, forging the heaviest elements in the universe. The shockwave raced outward at over 20,000 miles per second. Webb's spectrographs captured the chemical fingerprints of these newly created elements. For the first time, we were not just seeing a supernova, we were dissecting it in real time. Webb captured the flash, the expanding fireball, and the intricate structure of the ejected material in unprecedented detail. What Webb is showing us isn't just chaos, it's a beautifully structured event. This Type II supernova began with the core collapse, forming a neutron star. The rebound shockwave ripped the rest of the star apart. Webb's infrared vision peers through the debris, studying the newborn neutron star at the heart of the chaos. The expanding cloud of gas and dust is a masterpiece of cosmic chemistry. Webb's instruments reveal hydrogen, helium, and heavier elements, oxygen, carbon, neon, and even gold and platinum, crafted in the supernova's heat. The shockwave slams into shells of gas and dust shed by Betelgeuse, lighting them up in spectacular rings and filaments. This interaction creates a glowing, three-dimensional map of the star's final environment. Every photon captured by Webb carries information about the explosion, the synthesis of elements, and the dynamics of the interstellar medium. Betelgeuse is not just a spectacle, it's a perfectly timed cosmic experiment. Betelgeuse's supernova is a global event, a shared human experience. In the coming weeks, it will become a new, temporary star, visible even in daylight, outshining Venus. This unifying moment inspires awe and wonder across the world. The event has triggered a massive coordinated effort among space agencies and observatories, driving innovation in data processing and collaboration. Socially and culturally, Betelgeuse's explosion has captured the public imagination, inspiring education, art, and conversation. It's a powerful educational tool, making stellar evolution tangible and exciting. Most importantly, it reinforces the value of long-term scientific investment. Webb and neutrino detectors were ready because of decades of planning. The story of Betelgeuse's supernova is a powerful argument for why we must continue to explore and nurture our curiosity. The universe is full of wonders, and we must be ready when it chooses to reveal them. To grasp the significance of this moment, we turn to the experts. Dr. Evelyn Reed, astrophysicist on the James Webb team, put it simply, this isn't just an explosion, it's a story billions of years in the making. For decades, supernovas were distant, blurry mysteries. Now, Webb gives us high-definition, slow-motion detail. We're not just seeing the what, we're seeing the how. We're tracking shock waves, pinpointing where heavy elements are forged. This is ground truth for our models. It will rewrite textbooks. The supernova is a cosmic recycling plant. Elements created in Betelgeuse's heart are blasted into space, seeding the galaxy for future stars and planets. The iron in our blood, the oxygen we breathe, these were forged in events just like this. Betelgeuse is now seeding the galaxy with the raw materials for future life. Dr. Reed notes, the light from this explosion began its journey in the 15th century. Now, as it arrives, we have the tools and understanding to appreciate its message. It feels as though the universe timed this perfectly, sending us a message we're finally ready to read. This event is a dialogue between the cosmos and humanity. We are incredibly fortunate to be part of the conversation. The light show from Betelgeuse's death is just the beginning. The brilliant flash will fade, but the supernova's legacy will unfold for thousands of years. What's left is a rapidly expanding cloud of debris, a supernova remnant, and a mysterious, ultra-dense object at its center. The familiar red shoulder of Orion is gone, replaced by a growing nebula. The crushed core is likely a neutron star, so dense a teaspoon would weigh billions of tons. Astronomers will hunt for signals from this stellar corpse. If it's a pulsar, it will sweep a beam of radiation across space. The expanding remnant will become a laboratory for astrophysics, creating shock fronts and turbulent structures. Telescopes will watch as this cloud of elements cools and mixes with the galaxy. For us, the show continues. The nebula will become a new celestial wonder, visible even to backyard telescopes. Betelgeuse may be gone, but it leaves behind a masterpiece painted across the night sky. The death of Betelgeuse is more than a headline, it's a profound moment of connection. For a brief time, we are all united as spectators of a cosmic drama millions of years in the making. This event pulls us out of our daily lives and reminds us the universe is alive, dynamic, and ever-changing. The same forces that destroyed a star create the ingredients for new worlds and life. This is an invitation from the cosmos. Be curious, ask questions, seek understanding. When you look up and see that new point of light, you're part of a moment of discovery. Science is a fundamentally human endeavor driven by wonder. Let this event inspire you, encourage curiosity, support discovery, and celebrate knowledge. The light from Betelgeuse has traveled for centuries to reach us with a simple message: look up, the universe awaits.